I say there. Hello, chaps and chappies. Wheezencought's the name. Professor Wheezencough. I'd like to talk to you a bit today about the Earth. Now, isn't that neat out there? I'll bet you wish you were there. Just look at that marshland. Why, if you could see a little farther out, you would see the ocean. But if you look around where you are, you might see either a classroom or some trees, some grass, buildings, things like that. But if we could see what is a few meters below us, underground, we would see the same thing, whether there on the marsh or we're here where we are now. Every day, we walk or drive around on some part of the Earth's surface, and we see what is sticking up. But what can't we see? We know that subways run underground, that our water comes from wells underground, and that our sewer system's underground. Hopefully different places. But what do we really know about what is under our feet? Probably very little. Fortunately, scientists have been studying the structure of the Earth, and we can learn a lot about studying what they have discovered. Now, scientists have studied the internal or inside structure of the Earth for hundreds of years. The problem that the scientists have been faced with is that they cannot make direct observations. You can't exactly go down there and walk around. Still, they have gathered lots of information. Now, they've analyzed their data, and they've come up with some interesting theories about what the Earth's interior is like. Now, just how have these scientists collected information about something they can't see? Well, there are two main ways that they have been collecting their information. The first method involves drilling into the Earth. They can bring out sections from holes as deep as 8 kilometers into the Earth. Now, a kilometer is a little over a half mile, so 8 kilometers would be about 5 miles. Imagine drilling a hole 5 miles deep. The problem with drilling is the Earth is about 4,000 miles deep, or about 6,370 kilometers. Another way that scientists have been collecting data is by using seismographic equipment. Now, these tools measure the seismic or shock waves produced by earthquakes. Analyzing this data has given scientists some valuable insight into the structure of our planet. Now, once the information is collected and the data analyzed, theories are developed. And from these theories, scientists are able to create models. And just as the theories may change when new information is learned, the models may change as well. Today, scientists believe that the Earth is made up of 4 layers. The crust, which is the crunchy outer part, the mantle, which is the largest part of the Earth and where volcanic lava comes from, the outer core, which is molten iron, and the inner core, which we believe to be solid. Using this model, scientists have been able to explain many geological events, such as earthquakes, volcanoes, and the movement of continents. With this model, scientists hope to develop a better understanding of the past of our planet so that they might better understand the current events and better predict the future of our home. Remember that huge word, uniformitarianism? It means that what is happening today is probably what happened in the past. But let's compare the Earth to an egg for a few moments. Both have 3 main parts. Just like an egg, the outer layer of the Earth is hard and crunchy. It's called the crust. As far as scientists know now, all life exists either on the surface or within just a few meters of the crust. We live on the crust. All of our water, our lakes, our oceans, oil wells, even coal mines, everything we get from the ground comes from this crust. Did you know we have never been able to dig a hole through the crust? The deepest hole ever drilled by anyone is about 7 miles deep. Okay, now the crust is made up of different kinds of rock, but the 2 main types are granite and basalt. Basalt is much stronger than granite. The upper or continental crust is made primarily of granite covered by sedimentary rocks. You do remember what sedimentary rocks are, don't you? Well, beneath the granite we do find basalt. Basalt makes up the bottom of the crust. Ocean crust is made only of basalt. Since ocean crust is thinner, it has to be stronger than continental crust. Scientists refer to this crust as the lithosphere, the crunchy solid portion of the Earth. That word litho comes from the Greek word meaning rock or stone. Did you know that scientists believe the Earth's crust or lithosphere is broken into several segments or plates? They also believe these plates move or drift on hot molten material that is just underneath the crust, the Asthenosphere. Now, depending on whether it is made of continental crust or oceanic crust, these plates may be as thin as 5 to 7 kilometers, thick under the ocean, and its continental crust may be from 20 to 70 kilometers thick. Where would you expect to find the thick crust? I do hope you said the mountains. Well, it's egg time again. Remember, the eggshell is the crust, so let's see what the next part of the egg represents. Whenever we peel an egg, the shell is actually stuck to a very thin layer of plastic-like stuff. Well, the Earth has a very thin boundary or layer between the crust and the mantle. We call this the Mohovičić discontinuity, or MOHO for short. We will call it the MOHO. The MOHO is sort of like a fence between the crust and the mantle. Speaking of the mantle, it's the second layer of the Earth, and it is the biggest. The mantle makes up 80% of the Earth's total volume and 68% of its mass. It is 2,900 kilometers, or about 1,800 miles thick. It is definitely the heaviest part of the Earth. The mantle appears to be composed of silicon, oxygen, aluminum, iron, and magnesium. There seems to be greater percentages of iron and nickel as we go deeper into the mantle, however. Scientists tell us that the very top edge of the mantle has reached a point of gooiness, but it's not totally changed from a solid to a true liquid. It's kind of like very thick syrup or tar. They call this part of the mantle the asthenosphere, and the lithosphere actually slides upon it. As we go deeper into the mantle, the temperature gets hotter. At the top, it averages about 870 degrees Celsius, but down near the bottom it gets nearly 2,200 degrees Celsius. The core. The center of the Earth is like the yolk of the egg, with the exception that scientists actually believe the core is like two layers. There's an outer core and an inner core. This outer core is believed to be about 2,250 kilometers, or about 1,400 miles deep. The temperatures go from 2,200 degrees Celsius on the upper edge and gets as hot and hotter and hotter, nearly 5,000 degrees in the center. Scientists believe the outer core is liquid, very dense melted iron and nickel. This dense iron core is believed to help cause the Earth's magnetic field. Now, the inner core is believed to be about 1,300 kilometers, or about 800 miles in depth. Temperatures here are about 5,000 degrees Celsius throughout. They also believe this inner core is solid iron and nickel. It's solid because of the incredible pressure down on it. There may be as many as 2 million times the pressure on the inner core as on the surface. It's very important to remember that as we go deeper and deeper, both the temperature and the density of these layers increase. Well, that's a lot to take in, isn't it? Thinking about the Earth having 4 layers, that it's over 4,000 miles to the center, that the center is solid but over 5,000 degrees Celsius. Well, hang on to your hard hats, because the really strange part will come in a later lesson. Wait until we learn about plate tectonics and seafloor spreading. Well, ta-ta for now. There's actually 2 layers of the core, outer core and an inner core. The outer core is believed to be about 2,250 kilometers thick. The temperature goes from about 2,200 degrees Celsius on the upper edge, and it gets as hot as 5,000 degrees Celsius down near the bottom. Scientists believe that this outer core is liquid, very dense melted